wind turbine blade design. They're certainly always trying to get the most performance. And the new trend is trying to make them even more recyclable than they are right now. You can recycle anything. So we have to get circular, repurpose those, recycle those, and incorporate those into our manufacturing.
This is EnergyCast, and I'm Jay Downhauer. Today we're talking about recycling wind turbine blades. If you've ever been out to a wind farm, they're huge. Some are longer than a football field, and they don't last forever. As we discussed, many are being retired long before the end of their useful lives. This poses a huge challenge for an energy source whose primary value proposition is that it's green, right? It's renewable. But as some viral images have shown, these massive blades are not being reused. Instead, they're going to massive landfills that are among the largest you've ever seen. My guest has developed a solution, one that he says has the scale to absorb as many of these blades as the industry can give. It reminds me a lot of my time in the carbon capture sector. There are many great things you can do with CO2. We even met a company that could convert carbon dioxide from power plants into baking soda. But there's only so many cookies you can bake. What the carbon industry needed was ways to absorb millions of tons of CO2. That led to solutions in that case like enhanced oil recovery. Back to wind, the solution my guests have is one that would shred wind blades, mostly made of fiberglass, and combust them as an energy source that would offset coal in cement production. This wind blade composite residual could then be used as an aggregate in cement, so there's nothing to throw away. My guest says there may be many more solutions for these blades, but they now have a plan to make these renewables recyclable as well. My guest today is Chris Howell, Recycling Operations Senior Director for Veolia, the world's largest environmental service company. I came to know Veolia from my days in oil and gas, particularly water treatment. What I was not familiar with was the extent of the company's recycling, everything from plastics to trains to submarines. The latest venture with wind blades is an agreement with GE Renewable Energy. It took me a second during the interview to fully understand that the blades would be used as both an energy source and as a raw material for cement production. As we've discussed on this podcast in the past, coal and coal ash are also used in cement production. In fact, cement is one of the biggest ways coal ash is utilized after it's burned in a power plant. If you use the wind blade composites as an energy source to make cement, you can still use the coal ash, again used earlier in power plants, along with the wind blades. My guest says there's a net reduction in CO2 by burning wind blade composite rather than coal in cement production. Got it? Of course you do. I hope you enjoyed my conversation with Chris Howell. We're here with Chris Howell, Senior Director of Recycling Operations at Veolia. And Chris, you'll have to forgive me for thinking of Veolia as water specialists. I worked a lot in the oil and gas fracking sector. That's how I came to know Veolia. So is recycling a new venture for Veolia?
For Veolia, no. And Jay, I'm surprised that you went the water route first, because a lot of people don't realize that Veolia is the world's largest water and wastewater treatment company. It's been around for a very long time, over 165 years. What we are is the world's largest environmental services company. So recycling for us is in our DNA. It's what we do every day. And promoting circular economy solutions is what we do every single day. So no, recycling is something we've been doing for quite some time, and we do it for a number of different things.
Yeah, but mainly water recycling, right?
Water recycling is certainly what we do globally, but recycling of other things, the more mundane things, plastics, plastic bottles, steel, scrap, decommissioning of trains, subway cars, nuclear submarines, all of those are part of our recycling efforts.
Yeah. So that gets us to the matter at hand. And Chris, this is one of the biggest questions I've had about wind. And I'm so glad that I was put in touch with you guys because last summer I visited Dominion Energy's offshore wind farm. And though this didn't come up in the interview, the episode we did, you have to wonder what happens to all those huge blades once they reach of their useful life. What is currently happening? Because they have decommissioned, they have repowered wind projects that were built earlier, right?
Sure. Jay, there's a lot of interesting things you can do with end of life old wind turbine blades. You can make playgrounds out of them. You can make cell towers out of them. They just commissioned a pedestrian bridge in Europe made out of decommissioned or old wind turbine blades. Those are great, innovative applications for the wind turbine blades, but they don't provide the scale necessary to manage all of the blades that we're currently seeing in the market in North America and globally. There are very regular recycling methods for the metal portions of a wind turbine, but there hasn't been any real scalable solution for the wind turbine blades until Veolia came up with the innovation that we're now providing as a commercial offering to the industry. And that is for the recycling and repurposing of the wind turbine blades, which are predominantly fiberglass. And we have a solution for that now.
Yeah. So were some of these blades just being landfilled?
They certainly were. There's certain viral images of a landfill in Montana where a bulldozer is just putting dirt over wind turbine blades that were put in a landfill. There's nothing illegal with putting wind turbine blades that are end of life in a landfill. Unfortunately, that's not the most sustainable thing to do with them. So Veolia came up with a solution to prevent, mitigate, eliminate the blades from going to landfill should an owner want to utilize our offering and service.
That gets us to the announcement that Veolia and GE announced late last year, a partnership to recycle these blades for cement production. How did this come about and how will this work?
Great question, Jay. This actually started prior to the COVID pandemic. Veolia was approached in Europe to see if we had a solution for the end-of-life wind turbine blades. Veolia in certain countries was providing decommissioning services for end-of-life wind turbines, but we didn't have a solution at the time for wind turbine blades. So we started investigating several years ago what we could do with the wind turbine blades, and we went down a number of different paths of different technologies, trying to come up with a business solution that made sense. And it had to address the scale of the volume of materials that are available and what we might be able to do with them. Again, lots of neat ideas. Scale really becomes the main issue. You've got to be able to have the scale necessary in order to manage the blades. GE Renewables approached us and said, well, what about the repower that's going on in the US? Do you think those volumes would meet the business model criteria that's necessary for an investment? And we said, well, maybe. Let's look at it.
So you're basically recycling blades from what I would imagine would be some of the earliest wind farms. We'll get to the anticipated asset life in a second, but I would assume that you're dealing with those blades, and then just as time goes on and more wind farms were coming online, it should be a pretty solid book of business, right?
Yes and no. It's actually quite the opposite, Jay. What we're dealing with in the United States are blades that are being prematurely removed from service in order to repower existing units. Typical life is 20 to potentially 30 years. The blades that we're seeing in the United States are somewhere between 8 and 12 years old. And this is a result of what's called repower, taking the existing assets, removing the whole top portion of the turbine, replacing that generator, gear set, switch gear, and wind turbine blades with new, more efficient, higher technology equipment. Then the clock starts again for another 20 to 30 years. So the blades that we're seeing predominantly in the US are 8 to 12 years old. And to your point, as renewable energy continues to scale up in the United States, once the repower blades have been managed, then we'll start to see for a considerable time, those blades that are coming from more traditional end of life and from catastrophic events, lightning strikes, weather events, or catastrophic failure of components.
That's interesting. I didn't know that they were repowering before the end of useful life. So from what I read, and correct me if I'm wrong, Chris, it looked like the blades that you're recycling are going to a central recycling facility. They're not being recycled in a mobile setting out on site at the farms, right?
That's correct, Jay. We have our facility in Louisiana, Missouri. It's about an hour and a half north of St. Louis. We leverage the capabilities and the personnel that we have at this location in order to come up with a relatively central location to meet the needs here in the United States.
You see these shots of when they're bringing the blades out there, oversized load trailers. Has there been any talk about improving costs by mobilizing the effort and shredding there at the farm when you're ready to do that?
Great question. The thing to remember is when these blades are removed from the wind turbines, we don't have to treat them with kids' gloves like we did when they're erected in the first place. We do sizing of the units in the field. We'll cut the blades typically in the 40-foot lengths so that we can put them on standard flatbed trucks for transportation. We have evaluated and will continue to evaluate whether it makes sense to do shredding of some sort in the field. But you need to remember that whenever you do this type of work, you've got environmental permits, whether they be air or water permits, and establishing a number of different primary shred or sizing locations throughout the country would become rather problematic and expensive. What we're finding is the method that we're doing right now meets the market needs, and that is the blades are sized in the 20 to 40-foot lengths in the field, and then they're shipped here to us in Louisiana, Missouri.
Yeah, that's a good point. I'm sure that if you were setting up a mobile site, you'd probably be doing it powered by something like diesel generators, right? Mm-hmm. And so I'm sure you get this question too, since we're talking about renewable energy, is that during the recycling process, how much energy is used, right? How much carbon footprint is being taken to simply shred these blades for end of life, right?
Right. And GE Renewables was very, very aware and conscious of this. As a matter of fact, they hired a third-party company, Quantus US, to determine what the net carbon effect of blade recycling would be based on the processes that we plan to use and that we currently do use. And what they found out is that there's a 27% net reduction in CO2 emissions from cement production based on the manner in which we do it, and also a 13% reduction in water consumption. In addition to the displacement of coal, silica, limestone, and other minerals that are used in the making of cement.
Yeah, that's interesting that you're using it for cement. And so mainly the blades, the composite that comes out, I saw in the literature that it's being created and used in cement. And I've covered the importance of coal ash in the past. And there's certainly no shortage of that. And I think that the coal ash, the stuff that's kind of relegated to the ponds, it's filing a second life for cement. So does this composite from the wind blades complement coal ash? Are you kind of competing with it now? What's the story there?
Sure. Well, actually, two distinct differences. If you think about coal being burned to generate electricity and you end up with ash, that's one aspect. You could blanketly somewhat call that incineration because you do have ash that needs to be managed at some point and in some way. With the cement co-processing, there's no ash. The material has an energy value to it based on the resins that are in the fiberglass. Those BTUs then are used in the cement processing, and any residual that's left, what some people might think of as ash, that actually reports to the cement and it becomes a part of the cement. The silica, the calcium oxide, aluminum, small bits of iron are all chemical constituents necessary for the production of cement. So in addition to having the CO2 reduction by using it in lieu of coal, we're also displacing the other raw materials that are needed for cement. So it's a very elegant and relatively simple solution that provides the scale necessary, as I talked about before.
Okay, that makes a lot of sense. So we're using the wind blade composite material. It has BTU value. You're essentially combusting it in the cement making process instead of burning coal, right? And you can use both what's left over from the composite once it's been burned, just the same as you would coal ash in cement. Is it two uses?
Correct. The energy value is displacing coal that would normally be used in their process. And then the residuals that are left become raw materials that are part of the cement itself.
So that's good because that allows coal ash to continue to be used, but you don't have to use coal to create cement for an energy source. And you can use the wind turbine blade composite for both an energy source and the actual fill in the cement. Hey, what else is in these blades? We've talked about the composite. You mentioned fiberglass. I assume that there's some metal in a wind turbine blade. Is everything recyclable in a wind turbine blade at end of life?
Everything is recyclable in a wind turbine blade. It's whether or not it's economical or not. And so we continue to look at opportunities for it. But the wind turbine blade is primarily made of fiberglass composites and balsa wood. It has small amounts of iron and aluminum in it, and there's quite a bit of steel if you think about the root end of the wind turbine blade that needs to be bolted to the rotor. All of those studs that are at the end of the wind turbine blade, they're all bonded into the material or incorporated into the base or root of the wind turbine blade. And again, all of those materials are recyclable. There is some PVC foam as part of its manufacturing. And I tell people these are like chicken wings. All chicken wings are kind of the same, but everyone's got different recipes for them. And it's the same with the blades. Different technology providers over the years have gone through different generations and iterations of wind turbine blade design. They're certainly always trying to get the most performance out of these for the lowest cost. And the new trend is trying to make them even more recyclable than they are right now with new composites and new methods of construction.
What is going on with a blade that has reached the end of its life? It obviously doesn't have holes in it. Is it structurally breaking down? How does a wind turbine blade get old? And when do you know that it's time to pull it out of service?
The engineering part of me will just say that through fatigue over a period of time, that there's a finite life. There's not a gauge on the blade that says, okay, I'm done. But there are folks that definitely have that intellect and know what that is. If you think about the wind turbine blade, especially the 10 megawatt unit that you're looking on the offshore there, that tip speed of that wind turbine blade is sometimes close to 200 miles an hour. It looks like it's revolving very slowly, but if you actually look at how fast parts of that blade are going, and now you've got it making however many revolutions per day, at times a very high velocity, it's just going to wear out from a fatigue standpoint. And certainly it can also have impacts in the environment that it's in. I'm sure the offshore units, they'll have different types of materials to protect from the corrosion from seawater, which they don't have perhaps incorporated into the blades that we see onshore.
Yeah, it's certainly circular, right? And you mentioned it being 30 years. And that was really the age that I was hearing bandied about with Dominion's project. Now, of course, that's offshore and it's going to get probably beaten up a little bit more. But that is pretty much the lifespan of these blades, unlike some of the projects you're working on, given the opportunity to stay out in the field as long as possible.
Oh, absolutely. 20 to 30 years is typical life. And the onshore wind turbines that we have right now, from a size standpoint, are tiny in relationship to what we're going to see on the offshore blades. We'll still have to continue to innovate our processes and find other potential uses for materials as the materials themselves may change over time.
Yeah, believe me, when they took us out to Dominion, they took us on the boat. And the captain knew exactly what he was doing. I knew he was going to do this move where he went underneath the blades and let it swoop right over your head. And he must have stayed out there. He just kept backing up and trying to center us. So we were under those blades for a good 20 minutes. So if you didn't start to get a little bit of vertigo, you've got a stronger constitution than I do.
Yeah, the offshore is going to be really unique. And of course, then there's going to be a bunch of new challenges associated with offshore as it progresses and as technology advances there as well.
Yeah. By the way, the blade that we were under was a 10 megawatt, and I think the ones that they were planning on building are 14. So just imagine that 50% bigger. So the composite, again, BTU value in that also seems that you could use it for other kind of combustion process. What else can this composite be used for? I'm thinking of other kinds of building materials. I've talked to a company that was trying to come up with uses for coal, like shingles and wallboard, any other uses that have been identified for the composite, both pre and post BTU?
Right. And the answer is yes. There are quite a few alternative uses than cement co-processing. Again, it comes down to scale. Those processes and innovative ideas are progressing forward, sideways, and sometimes backwards. Again, just to make a business model work. You can recycle anything. Whether or not you can recycle anything at a cost that is competitive or that makes sense for the market always becomes the critical criteria for pursuing a business model associated with it. So yes, People have looked at opportunities to grind the material down, somehow pelletize it, and then perhaps use it as a feedstock for the manufacture of other composites made into a number of different things. They've looked at it for the manufacture of a different type of wallboard that may go into a home or a business. Veolia has its ear to the ground on those and is part of some of those teams from a collaborative effort to come up with other solutions. We want to diversify as much as possible where the material can go so that it's not pigeonholed into just one location and one opportunity.
You mentioned some of the things you're already recycling. The submarines was one that really poked out. What other recycling ventures are you looking into? I'd have to assume that solar panels would be something very analogous to what you're doing right now.
Absolutely. From a renewable energy standpoint, we are definitely looking at circular opportunities there. Veolia has a PV panel recycling facility in France, and we've been doing that for quite some time. We are looking to see if we want to export that knowledge and that technology here to the United States and other geographies. Certainly, the newest generation of batteries is incredibly attractive, particularly for Veolia. We have an agreement and JV in Europe already for the newest generation of batteries, and we're putting a lot of time and effort in determining what we need to do here in the US and other geographies. Obviously, China is a huge geography and a huge market for wind and other renewable energy. So what we're doing here in the United States, we would certainly hope to be able to export. And what we're doing in other countries, we'd certainly look at opportunities to import or tweak that specifically for our market needs here.
Yeah, I'd have to imagine there's just too much out there on the system for you to just throw it away. So this has got to be circular. It looks to me like that's a big part of what you guys are planning. That's exciting to hear.
Well, I think what's really cool with the industry is we are in such an instant gratification society that people are now realizing as population growth has increased that we are all on this spaceship together. And there's a finite amount of resources on this spaceship we call Earth. So we have to get circular. We've got to mine and get materials that we've already used and repurpose those, recycle those, and incorporate those into our manufacturing.
All right, Chris, we're going to finish with a lightning round of your thoughts on different energy technologies, starting with natural gas.
It's very plentiful here in the US, and it's a relatively clean source of energy. I would certainly promote natural gas.
Crude oil.
Crude oil for transportation is certainly taking a different turn with the electrification that we have of the automobiles. I don't think that electrification of the automobiles 100% is going to be the sole solution. We still have large trucks and things that we need to get around. So crude oil for transportation for trucking is certainly going to be part of the solution until we come up with another one. And I suspect for trucking, it'll be some kind of hybrid that might be hydrogen combined with electricity.
Nuclear.
I'm a firm believer in nuclear. Small modular reactors, SMRs, is, I think, the new future for nuclear power.
Coal, and I'll add coal with carbon capture.
Coal with carbon capture is certainly an attractive application, especially for countries that aren't as advanced as we are in some of the others. You've got to look at the ability for some countries to use the resources that they have at hand in order to serve their population. Finding a method for coal use in those countries is going to be very important.
You guys, wind.
It's a great application for us. I think there's going to come a point where people are going to wonder how much wind you can actually put in place. And there are certainly wind corridors all over the globe where wind is a great solution, but the wind doesn't always blow in all locations. So it isn't the end all be all.
Solar.
Like wind, there are great places for it. And there's actually been more advancement in solar than there has been in wind over the last decade. We're actually getting ready to install solar panels on our production facility here in Louisiana, Missouri.
Biofuels.
The old adage is, if it wasn't mined, it's grown. So the ability to take biomass and convert it into energy is something that we continually need to look at, but balance that with the amount of water necessary for crop production.
Hydroelectric.
Great. And again, it's very geographically dependent. Certainly, a lot of people might say that hydroelectric can harm the environment in some ways. And there's certainly quite an effort to remove some run-of-river hydroelectric dams. And certainly drought plays into that as well. And as we have climate change, hydroelectric is going to be impacted.
Geothermal.
Really cool. And again, it's geographically dependent. To me, it's a great renewable energy source because the water that you remove from underground, you end up putting back underground. And so long as Mother Earth continues to be warm or hot, it's a great application for energy.
Energy storage.
The cool thing that's happening with the electrification that we see, for the first time ever, we can store potentially large amounts of electrical energy generated during off-peak times. Hybrid technology incorporating batteries with wind or solar is going to be a great advancement for us.
Electric vehicles.
Really cool, expensive at the moment for a lot of the public. And so I think once they start to advance, the price will come down. The electric vehicles that I've seen are fantastic pieces of technology that I'm looking forward to.
Energy efficiency.
We certainly need to be more efficient with everything that we do. So driving energy efficiency, driving the ability to reduce the amount of energy necessary to do anything is where we want to be. If we can make things just more energy efficient, that reduces that amount of energy capacity that we need.
And then finally, fusion power.
I read an article that we're pretty darn close to having that be a positive endeavor, i.e. they'll put out more energy than it takes to produce it. Fusion will be rather unique. I wonder, though, if fusion energy will go the way of the first generation of nuclear power. It's something that sounds great, looks great, but will it actually pan out and will it be economically feasible will be where the rubber meets the road.
All right, Chris Howell, Veolia, thank you so much for your time.
Hey, Jay, thank you. It's been fun, and we're really excited about the different things that we're doing here at Veolia.
That was Chris Howell, Recycling Operations Senior Director for Veolia, based in Missouri. Veolia says more than 90% of a wind blade can be used in this process with GE, 65% as a raw material in cement plants, and 28% transformed into energy required for the chemical reactions in the kiln. I want to thank Chris for his time, as well as Andy Hoagland at Rasky Partners for setting this up. You can find plenty of pictures for this episode on Energy-Cast, as well as on Instagram and Parler at Host Energy, and Twitter at Host Energy Cast. All guests are sent the raw and completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 133. Be sure to join us next week when we learn how a former guest of the show is developing a potentially world-changing solution for nuclear waste. Until then, I'm Jay Downhauer. We'll see you next time.